Today we are going to learn about Docker, building effective virtual environments. You will acquire the skills to design and implement efficient Docker environments for scalable applications. Welcome to our session on Docker, building effective virtual environments. Docker is a powerful platform that enables developers to build, ship, and run applications inside containers. It brings immense benefits such as consistency across multiple environments, scalability, and resource efficiency. Unlike traditional virtual machines, Docker containers share the same operating system kernel, making them lightweight and fast. Throughout this video, we will explore Docker's capabilities, starting from creating Dockerfiles to managing multi-container applications with Docker Compose. By the end, you'll be well equipped to harness Docker for scalable and efficient application deployment.
Docker is an open-source platform that automates the deployment of applications inside lightweight, portable containers. These containers encapsulate everything an application needs to run, ensuring consistency across different environments from development to production. One major benefit of Docker is its efficiency. Containers start almost instantly, consume less memory, and allow for more efficient use of the underlying hardware compared to virtual machines. Docker's scalability is another key advantage, allowing developers to easily manage and scale applications horizontally. This has made Docker an integral part of modern development workflows, enabling continuous integration and deployment. In the real world, companies use Docker to streamline their development processes, improve collaboration between teams, and reduce costs associated with infrastructure.
A Dockerfile is a text document that contains all the commands needed to build a Docker image. It's the blueprint for your containerized application. To create an effective Dockerfile, start with a lightweight base image such as Alpine to optimize performance. Each command in a Dockerfile creates a layer in the resulting image, so it's crucial to minimize the number of layers and reduce image size. Use multi-stage builds to further streamline your images by separating the build environment from the runtime environment. This reduces the final image size and enhances security. Avoid common pitfalls like using latest tags, which can lead to unpredictable builds, and ensure you clean up unnecessary files to keep your images lean. Building Docker images is a straightforward process that involves executing the Docker build command alongside a Dockerfile. Each instruction in the Dockerfile results in a new image layer, which Docker caches to optimize future builds. It's important to tag your images with meaningful names and versions for easy reference and management. Tags like v1.0, latest, or stable can help differentiate between different stages of development. To ensure your images are functioning as expected, Docker provides tools to inspect image metadata and history. Regularly updating and maintaining your images is crucial, especially when dealing with security vulnerabilities. By following these best practices, you can ensure your Docker images remain efficient and secure.
Once you have a Docker image, the next step is to run it as a container. The Docker run command is your primary tool for starting containers. You can specify options such as port mapping, environment variables, and volume mounts to customize the container's execution environment. To manage the lifecycle of your containers, commands such as Docker start, Docker stop, and Docker restart are essential. You can attach to a running container using Docker attach or execute commands inside it with Docker exec. Monitoring container logs is crucial for troubleshooting, and Docker provides log management tools to view and filter log output. These commands form the foundation of effective container management.
Docker's networking capabilities allow containers to communicate with each other in external networks. By default, Docker creates a bridge network that containers connect to. However, you can create your own networks using the Docker network create command. Custom networks provide isolation and control over container communication. Linking containers is a deprecated feature, so using Docker's modern networking features is recommended. Bridge networks are used for standalone setups, while overlay networks are suitable for multi-host deployments and Docker Swarm. Security is also a key consideration. Ensure you use firewalls, secure ports, and encryption to protect container communications.
Docker volumes are the preferred method for persisting data generated by and used by Docker containers. Volumes are stored outside the container's file system, making them persist even when the container is removed. You can create a volume using the Docker volume create command and mount it to a container with Docker run v. There are two main types of volumes: bind mounts, which link directories on the host file system to the container, and named volumes, managed by Docker. Each has its use cases, but named volumes offer better isolation and management. Proper data management practices, like regular backups and monitoring, are vital for ensuring data integrity and availability in Docker environments. Security is a critical aspect of any Docker deployment. Containers, while isolated, share the host kernel, which can pose security risks if not managed properly. Docker's security model includes features like user namespaces, which map container users to host users, reducing the risk of privilege escalation. Regular vulnerability scanning of images is crucial. Tools like Docker's built-in security capabilities and third-party scanners can identify and address vulnerabilities. It's vital to follow best practices, such as running containers with the least privilege, using read-only file systems, and ensuring all images are up to date. By implementing these strategies, you can significantly enhance the security of your Docker environments.
Docker Compose is a tool used for defining and running multi-container Docker applications. With Docker Compose, you can use a YAML file to configure your application's services, networks, and volumes. This file allows you to manage complex setups with ease, as all the necessary components are defined in one place. To deploy an application, simply execute Docker Compose up, and Docker Compose will start and link all the containers as specified. It's particularly useful for managing dependencies between containers, such as a web server and a database. Docker Compose also supports scaling, allowing you to increase the number of container instances with a single command, making it ideal for applications that require high availability and quick updates.
For more complex networking requirements, Docker offers advanced features such as overlay networks, which are essential for Docker Swarm deployments. Overlay networks span multiple Docker hosts, allowing containers on different machines to communicate securely. Docker supports network plugins that extend its networking capabilities, offering features like advanced routing and load balancing. Service discovery is built in, with Docker providing an internal DNS that resolves service names to container IPs. Network policies and segmentation can further secure and control traffic between containers. Troubleshooting network issues involves using Docker's built-in network inspection tools to diagnose and resolve connectivity problems, ensuring smooth and reliable application deployment.
Docker Swarm is Docker's native clustering and orchestration tool, enabling the management of multiple containers across various hosts as a single entity. To set up a Docker Swarm cluster, you initiate a Swarm manager and add worker nodes. With Swarm, deploying services becomes straightforward, as it handles container scheduling and deployment across the cluster. Swarm scaling capabilities allow you to adjust the number of service replicas dynamically, ensuring your application can handle varying loads. Additionally, Swarm provides tools for monitoring service health and performance, making it easier to maintain a reliable and efficient containerized environment. Proper management and monitoring of Swarm nodes are crucial for maintaining a resilient infrastructure. Congratulations on completing this journey into Docker, building effective virtual environments. We've covered the essentials of Docker, from creating Docker files and building images to running containers and orchestrating multi-container applications with Docker Compose and Swarm. Security and best practices are paramount to ensuring a robust and secure environment. As you continue to explore Docker, remember that its ecosystem is vast, with constant updates and new tools. Future-proof your applications by adopting Docker's scalable and efficient methodologies. We encourage you to continue learning and exploring Docker's capabilities through the many resources available online. Thank you for joining us, and happy containerizing.